Today in Capechi's Corner, we're going to look at areas of regular polygons. Now, when we're finding the area of the regular polygon, we need to understand a few of the vocabulary words and how they work within the polygon. The center of a regular polygon is the center of the circumscribed circle. So what happens, for instance, in this first diagram, if I were to just do a quick sketch and I made a square here. The square is inscribed, and the circle is circumscribed about that polygon. There's my center right there. Now the radius of the regular polygon is the distance from the center to the vertex. So from here to here is my radius. The central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices. So I have one radius that I've already drawn, this is the other one. So that makes this a central angle right here. So in this case, it's a four-sided figure. I actually have four central angles. So I know the circle has a total measurement of 360 degrees. If I divide that by four central angles, I know that each central angle is 90 degrees. Now in my next figure, I did a quick sketch of a pentagon. So I know if I have 360 degrees again in the circle divided by 5, because the pentagon has 5 sides, therefore there are 5 central angles. I know each central angle has a measurement of 72 degrees. Now the last vocabulary word we're going to talk about is the apothem. That's probably a new one that you haven't heard before. The apothem of a regular polygon is the perpendicular distance from the center of the polygon to a side. So for instance, in my diagram down here, it's perpendicular from the center to the side. And the biggest thing to remember is that the apothem and the radius are not the same. We just said that the apothem goes from the center and is perpendicular to a side, and the radius goes from the center to the vertex of the regular polygon. So when we're looking at the area of a regular polygon, its area is equal to 1/2 times the apothem times the perimeter. Now one thing we have to remember here, the perimeter is all the way around. So if I were to find this piece right here, which is x, we can't forget that this is x along here, so this whole piece is 2x. So for instance, if I had a number such as 4, if I know 4 was here, this side would be 4, this whole piece here would be 8, and in this case this is a 6-sided figure, so 8 times 6, our perimeter would be 48. So you really have to pay attention to the measurements and the diagram while you're finding the area of the regular polygon. Now we're going to look at a few examples. The first one says find the area of a regular hexagon with apothem 9. So that diagram is already marked with the apothem 9. So one thing I have to try to figure out, I know that the hexagon, remember if I bring this down here, my central angle is going to be 360 divided by 6 sides, and there's going to be 6 central angles, so that's going to be 60. Now that apothem divides that triangle that I made, the bigger triangle, into 2 congruent triangles. So what happens then is my whole central angle is 60, but when I divide that into 2, my one side's going to be 30. Again, this is perpendicular, and so I'm left with a 60-degree angle down here, so I have a 30, 60, 90 triangle. So now, in using the formula, I need to know the apothem and the perimeter. I already have the apothem, so I need to find one of the sides over here. So I'm given the long side. Remember, the long leg of a 30, 60, 90 is equal to root 3 times the short, which is x. So my long, I have 9 is equal to root 3 times x. Divide both sides by root 3. I have 9 over root 3. I need to rationalize that denominator. Top and bottom by root 3, and I have 9 root 3 over 3. So I get 3 root 3. So this piece right here where x was, I'm going to erase that now and I'm going to put 3 root 3. So if this piece is 3 root 3, again we said we had a congruent triangle, that piece is 3 root 3. So this whole side here has a value of 6 root 3. Now that's one side of the hexagon. There are 6 sides in a hexagon, so the perimeter is going to equal 36 root 3. So now when I work with my area formula for my regular polygon, I have 1/2 times the apothem, which is 9, times the perimeter, which is 36 root 3. And when I multiply all of that, I have 162 root 3 units squared is the area of that regular hexagon. Our next problem says find the area of a regular polygon with 9 sides inscribed in a circle with a radius of 10. So if I extend this just as a visual to remember that that's my central angle right there. So the first thing I have to do is figure out what the measure of that central angle is. So I have 360 divided by 9, so each central angle is 40. But remember, I have to divide that in 2. So what that means is this central angle right here is going to be 20. There's my 90 degrees. So again, this is my radius and this is my apothem. My radius we were given is 10. So in order to find the area, I don't really need the radius. The radius is going to help me here, but I don't need that value. So I need the apothem, and I also need the perimeter. So I'm going to label this Y, and I'm going to work with that. Now again, because my angle is 20 degrees and I have a right angle, I'm going to have to use some trig functions. So I'm going to use cosine of 20, which is adjacent over hypotenuse, so it's going to be A over 10. And I'm also going to use my sine. I'll use my sine of 20, and that will be my opposite, which is y over the hypotenuse, which is 10. So when I do my calculations, I have A is approximately 9.40, and y is approximately 3.42. Now the thing with that, remember this is this piece right here, I need the whole side. So I multiply that by 2. So one side is going to equal 6.84. Now again, there's 9 sides, so the perimeter is going to be 61.56. So now when I put all my information into my formula for my regular polygon, it's 1/2 times the apothem, which is 9.40, which is, and also then I multiply it by the perimeter, which is 61.56. So my area is equal to 289.33, and that's units squared. We're going to find the area of a regular hexagon with perimeter of 72. So this is our last problem for today. Now remember, when we're talking about regular polygons, we're talking about sides that have the same measurements and the angles have the same measurements. So we're going to start as we have been with the circle is 360 degrees. There are 6 sides and 6 central angles. So this central angle has a measurement of 60. I'd like to draw this other side in, just it gives me a nice visual to work with. So I know that my central angle is 60, so this piece right here is 30. That's 90 there, and this is going to be 60. Now, since the perimeter is 72, and there are 6 sides, I know that each side has a measurement of 12, so that makes this piece right here 6. So that makes my long leg is going to be 6√3. So when I find the area of this regular polygon, I take 1/2 times the apothem, which is 6√3, times my perimeter, which was given to me, and that gives me a value of 216√3 units squared.